Hey everyone, I think we just had a little accidental invasion from the iOS mini bootcamp instructor. So sorry about that. Maybe next week I'll jump into his live chat just to troll him back. Um, but welcome everybody. It is night 4 of the Web Development Mini Bootcamp, Web Dev 101 with Lambda School. My name is Deandra Ryan Moss. I'm your instructor, and I will be teaching you guys tonight live from Seattle, Washington, where the sun is actually shining just a little bit. So yeah, it's great to have you guys here. Those of you who are watching live, I hope you're in Slack. Let me know what's going on throughout, and I'll answer questions at the end. And everyone who's watching it after the fact, that's cool too. So tonight we are going to be talking more about control flow. Last night we started JavaScript. I showed you guys the basics, and at the end we got a little peek into this concept called control flow. And so we're going to be exploring that in a lot more detail tonight. But before we get into coding, let me talk to you a little bit about Lambda School. So as you all know, Lambda School is a really awesome all-online computer science and web development immersive. So it is a 6-month full-time program that's Monday through Friday, and a new section starts every single month. So if you guys are interested in applying, getting started, there's lots of opportunity for that. Reach out to Karen, Zachary, and Slag. We also do offer a part-time course that runs in the evening. That runs for a full year instead of just the 6 months. And that only starts twice a year, but we have one starting next month. So there's opportunities if you're interested in our part-time program. So one thing that I've mentioned throughout pretty much every lesson that I want to talk about in detail is this idea of de-risked tuition. So when I went through my coding bootcamp, I had to pay a giant sum of money up front, which was kind of scary because I didn't know if I was going to get a job. Oops, sorry about that. I didn't know if I was going to get a job. I didn't know if that was going to pay off or not. It ended up paying off great, but it was still a little scary. And I know other people who weren't able to pay the tuition, which meant that they either had to go get a private loan or they, just couldn't attend. And Lambda School did not want to be set up that way. We wanted to make sure that this education is available to anyone who is interested and able and willing to learn. So while you can pay tuition up front if you want, you don't have to. You can pay 0 at the start. And what happens is only after you have been hired do you have to pay that tuition back. So what happens is once you get a full-time job in the field making $50K or over, you'll be sharing a piece of your paycheck every single month for 2 years. And in that way, you can slowly pay your tuition back. So the risk is on us. If for some reason you go through and it ends up not being the right thing for you, then no harm, no foul. Maybe you spent a couple months exploring something, but you haven't forked over a bunch of cash. So I think that's really cool and a really great way that we make this education accessible. So once again, if you're interested in starting the application process, or if you have any questions about that, Karen Zachary is available in Slack and you can talk to her. So that's a little bit about Lambda School, the main curriculum and our tuition model. Right now we are in the awesome 2-week free course of Web Dev 101. So this is the last lesson of tonight, tonight is the last lesson of this week. And then next week we will start again and do Monday through Thursday once again. So thank you guys for sticking with me so far. Let's do some JavaScripting. I'm going to share my screen. We'll do a little review about what we learned last night, and then we will talk about all sorts of other cool stuff with control flow. So let's do it. Okay, so I have over here in my screen, I'm in Replit as a reminder. Replit is a sandbox environment that lets us write little chunks of JavaScript code and run them on the spot. And I have declared 2 variables up here. So let's go over the variable declaration syntax. I'll remind you guys about different types of objects in JavaScript, and then we'll talk about some other cool stuff. So up here, I've started by creating this name variable. So to create a variable called name, I've used the const keyword followed by the name of the variable, which in this case is name. And then I've used the single equal sign to assign a value in. And the value I'm putting in name is the name of Prentice. So this name is a string. We can tell it's a string because it is in quotes. And strings represent bits of text, whether it's words, letters, single characters, or even just symbols and gibberish and nonsense. Anything is considered a string as long as it is in text. And then finally, I end my statement with a semicolon. Semicolons are important, but they're easy to neglect because a lot of the times if we leave off semicolons, it's not a big deal. The code won't crash. But sometimes if we leave off semicolons, errors can be introduced in our code. So it's much better to play it safe and put a semicolon at the end of every statement. So that's my little pitch on semicolons. So we've stored this value of Prentice inside of a variable called name. And because we use the constant keyword, this value is fixed. There's no other value that can be stored in here. So we can use that name variable to look up the value, but we couldn't change it to something else if we wanted. We would get an error because const means that name is going to be constant. On the other hand, we also have a different keyword called let. So I'm using let for my age variable, and I set that equal to the number of 92. 92 is, or sorry, numbers are another JavaScript object, and we can tell that there are numbers because not only is there a number here, but it's not in quotes. So if I'd put that value in quotes, it would be a string. As is, it is a number. And because age, we declared age using let, we can change that if we want. For example, we could use the plus plus operator, which we know increments the value by 1, and then we would see that 93 is now stored in here. So the difference between const and let is that constant is a fixed value. We can never change it, whereas let is mutable. We can increase, decrease, or totally change what's stored inside of that variable. We could redefine it to being a phrase for some reason. I don't know why we would put a phrase into a variable called age, but we can if we want. So I saw that there was some chatter in Slack right before class about another variable keyword called var. So the reason I didn't introduce var last night is because I don't want you guys to use it. Var is kind of the old way of doing things. Old, just like Prentice, who is 92. But var isn't actually that old. But up until a couple of years ago, var was our only keyword. And var is mutable like let, but there's one kind of subtle difference between them that I will go over later. So in old code, you will see var all the time. So you need to know what var is because it's still in a lot of older code bases. But moving forward, it's better to use const and let. For one, it's good to differentiate this idea of is my variable constant or will it change? There's also some cool scope stuff going on, which we will see shortly. So just so you know what var is, it's just another way of declaring variables. It looks really similar to what we've seen so far. So yeah, we could still look up values in it. It works pretty much like these other two, but once again, it's a little outdated, so we want to stay away from var. So that's a little review of declaring variables and two data types. We had strings, numbers. We also have Booleans, which are just true or false. We set them equal to the keyword true or the keyword false. We also have the null value and undefined values as well. So those are a couple different data types, and we're going to play more with all 5 of those types tonight. So the other thing I wanted to review with you guys is just this if-else statement that we went over at the very end last night. So the if-else statement is an example of control flow. Control flow is where we as the programmer kind of determine what is going to run and what isn't. By default, every line of code is going to run in order. But when we add control flow in the mix, things get more subtle. So we might say, so to use the example from last night, we had this variable called raining. And actually, I'm going to set raining with let because, as we know, it can change from one moment to the next whether it's raining or not. So we might say if raining, oops. Okay, so I've set up an if-else statement. Let me review the syntax of this for you guys. So we start with the keyword if, and then in parentheses, we have some sort of condition. So this is the part of the if statement that's going to tell us which of these should run. If this is equal to true, our if block will run. Otherwise, our else block will run. So if raining resolves to true, then we want to stay inside. Otherwise, we want to go outside and play. So after our condition, we have these curly brackets, which start and end the if block. And we can just write code as usual within here, but it will only execute if this is true. Following that, we have the keyword else, and then more curly brackets to denote the else block. So same thing in the else block, which is that we can write as much code as we want in here, but it's only going to execute if this condition is false. So just a few more notes. I mentioned semicolons earlier. Notice that we don't put a semicolon at the end of the if or the else block. That's because the curly brackets themselves denote that we're coming to the end of a section, so we don't need the semicolon there. But everything inside here should have a semicolon at the end. The other thing I want to mention is tabbing. Just like in HTML and CSS, the code won't break if we don't tab, but it will be pretty hard to read. So we want to practice good form with tabbing and spacing our code. So everything inside of an if or an else block should be tabbed in. That will make it really clear to ourselves and to our fellow developers where our if block starts and ends, where our else block starts and ends. So let's go ahead and run this. And another little review is this console log statement. So console is this global object. So it's this thing that's built into the language. It's an object that we can access automatically. And it has this very nifty method attached to it called log. So remember, we execute methods using parentheses, and we can pass values inside of them. And in the case of console log, whatever we pass inside is going to be logged to the console. The console is this mysterious little sidebar here that exists on every website, and we can use to give ourselves feedback or get feedback from other developers. In Replit, the console appears in white. So in Replit, there's kind of a mocked out version of the console to let you see what's going on. So anything in white over here is the console, whereas the value in green is just the resolution of whatever our last line of code is. So there you have it, a little bit of a review of control flow. So this is really nice because we could take a variable like this, whose value might change, maybe change based on user input, or if we're being really sophisticated, we might actually write something that queries a weather database and actually live updates whether or not it's raining so that we can see which value should be logged to the console. So there is a little review of the basics of control flow, this if-else statement, and we also took a moment to talk a little bit about global objects and methods and the console within that. And now that we have that basic if-else statement in place, we can start to play around with it and do some more fun stuff. All right, so let's see. I want to talk about scope next. So, scope. So the word scope in programming is pretty similar to how the word scope would be used otherwise. You know, you might say, if we're discussing politics and someone jumps in and brings up, you know, their grandma's funeral, you might rudely say, that's outside of the scope of this conversation, which means it doesn't fit. And there's something like that that's formally defined in JavaScript. And so for starters, when we're just writing regular code here, you know, just starting to type code, we are in what's called the global scope. So everything exists in the global scope. For example, I mentioned that console or math are global objects. That means they're available in the global scope. As we know, these keywords that we've been playing with, like let or false, are also available in the global scope. So everything I've taught you so far is stuff that's available in the global scope. And as well, when we declare a variable, so right here we declared this raining variable, and we did it just outside in the regular JavaScript world, which means that raining is available in the global scope. So anywhere in the code, we could type the word raining and have access to it. So we certainly have access to it right here. So if I right below console logged raining, I could see that it was defined and I can see what the value of it is. I could also put this within my if block and it would be available. Well, not there because the if block isn't running right now. Let's set that to true. And it's available inside of the if statement too. It turns out though that when we go inside of our if statement, we're in a new scope. So we're in the if scope here. And we're in the else scope here. And you could just kind of in a more general sense call both of these block scope because we're in an if block in one case and we're in an else block in the other. So there's a new scope that's created when we do our if statement and our else statement. So as I mentioned, the global scope has like an all access pass. So anything that exists out here globally is going to be available everywhere. This is like our VIP variable. It can go wherever it wants. But the opposite isn't true. So check this out. If I created a new variable in here that said, let weather equal bad. So now I've created a variable inside of this if scope. So the deal is that this is available as long as the if scope is in play. So if I tried to console log this weather variable down here, I could see that it appears. But let's try and console log weather outside of my if statement. I get a reference error. Weather isn't defined. And that's because JavaScript is set up in this way where when we declare variables within a scope, they're only available as long as the scope is around. And this is one of those rules that when you're beginning programming, it might seem kind of annoying or frustrating, but it's actually designed this way very intentionally. It's actually extremely convenient that we can have this sort of secret scope that appears here because we can create variables that temporarily exist. And then once this is over, they're not bogging us down anymore. So it's actually really nice that we can do this. And it actually kind of, just like I talked about with this idea of const yesterday, it forces us to be good programmers because if we're creating something that should be available globally, we should create it on the outside. So, and this is another example this is an opportunity for me to tell you a little bit more about why let is a really useful variable. Because if I had done var here, notice that this weird block scope rule doesn't apply to this old keyword of var. Once var is declared, it's available everywhere. So it turns out that let is kind of cool and sophisticated because it has this block scope feature where when you declare a variable with let inside a block scope, it's only available in that scope. So this weather variable is only available until the curly bracket ends. It's kind of like the Cinderella syndrome where after the curly bracket ends, it turns back into a pumpkin or undefined. And let me once again, also bring const into this. So notice that if we do const, the same thing happens. So const also has this kind of block scope feature. So because we're going to try and stick to const and let, we need to know this rule. So takeaways from this little scope lecture are, one, that scope exists. There's something called global scope that exists everywhere. But then when we start to get into things like if statements and else statements, the rules change. And we'll see more and more examples of scope as we learn different cool things we can do in the language. The other takeaway is just this understanding that const and let have this kind of extra cool feature. So anyways, that is my little scope spiel. Scope is kind of a difficult concept to really, truly internalize. So I did just want to introduce it to you right now, but we'll be talking a lot about scope. Pretty much every time we learn how to do something new in JavaScript, we'll be talking about how scope applies to it. So I want you guys to start thinking about scope right now, but I don't expect you to have a full idea of what it is and how it works until we're a little farther into this class. So, all right, so that's scope for you. Let's go ahead and move on to some other cool stuff we can do with if-else statements. So as I showed you last night, this doesn't necessarily have to be a directly a Boolean variable. We could also put some other cool things like comparisons in here. So if we had, let's go ahead and create some X's and Y's. So if we wanted to, we could put a comparison operator in here. So for example, we could do if X is less than Y, which it is not. So, and now our log statements don't make quite as much sense anymore. So let me change those. So because this comparison resolves to false, we can use that inside of our if statement. So we could compare using less than, greater than or equals to. We can also compare directly with the triple equal sign. So the triple equal sign is the way that we determine equality. So the single equal sign in JavaScript means assignment. The single equal sign will never be used to compare. It is only used to assign variables. The triple equals is our is what we use to compare values. So so there are actually two different comparison operators for equality in JavaScript. The other is double equals. So double equals is kind of weird. It is the rules are a little more loose for double equals. So for example, these would be considered equal. We know that the type is different, but the value is kind of the same, right? In the 5 versus the string 5. So with the triple equals, it's going to compare the type as well and see that it's false. So for you guys, just stick with the triple equals for right now. I want you to be aware the double equals exists, but I want you to master the triple equals before you start playing with the double equals. So just be aware it's there, but for comparing two values, triple equals is usually the way to go. And notice that we don't just have to compare numbers with this. We can also compare strings. So if I have two strings that are slightly different, this one has the equal or the exclamation point, this one doesn't, then this will be false. So we can compare pretty much anything. We could compare two null variables if we wanted. We could compare null versus undefined. The triple equals is this really useful tool we have to tell if two variables are equal to each other. If we want, we might be interested in seeing if two variables are not equal. So remember our not operator from last night? We just get rid of our first equal sign and replace it with a not. And so now it's true. So this is where we get kind of confusing. It is true that these are not equal. So our if statement runs. So that is a way that we can use the not equal sign to as our condition within our if-else statement. So yeah, those are some more comparison operators. Let's talk now about something called truthiness. So far we've seen a couple different options of what can be inside of here. So we saw that we can, well, first of all, we can just drop a Boolean directly into our if statement. That's not very interesting, and you're probably not ever going to do that in the real world, because if we've hard-coded in a value of true or false here, then what's the point of having an if-else statement? If it's always going to be false, then why even bother with an if-else statement? So you can do that, but you really wouldn't do that. So the next thing we might see in here is an actual variable set equal to a Boolean, like this condition that we could change to true or false. Finally, we saw that we could actually compare something. So we could do if 3 is less than 5, and that's of course true. But as it turns out, this condition could actually be any variable type. So there's something called truthiness and falsiness, which I always feel like I'm going to spell wrong because these are fake words. So I spell plenty of real words wrong as well. So that's neither here nor there. Anyways, sorry, getting derailed. Truthiness and falsiness. We know that, of course, the Boolean value of false is false and the Boolean value of true is true. But it turns out that all other objects you can create in JavaScript have a truthy or falsy value. that means that they are considered true by an if statement or considered false by an if statement. So let's play around with these. I'm going to start with a string. So notice that if I put a string in, or the string hey, that the if statement runs. We get if log to the console. That means that this condition is considered truthy. So it doesn't equal true, but it's considered truthy. So if I put in, even if I typed out the word false, that's still considered truthy. And it turns out that all strings are truthy except the empty string. So if I do the empty string, and that's just a pair of quotes with nothing inside of it, that's considered falsy. That will trigger our else statement. So once again, we're exploring with non-Boolean values. Each have this truthy or falsy value, which means that they're considered by if statements to be true or false. So there are strings for you. And we know that the empty string is going to be considered falsy. So let's explore some numbers. So if I put in 9, we got if over there. That means it's considered truthy. Actually, I'm just going to change this to truthy and falsy. So 9 is truthy, 1 is truthy, negative 1,000 truthy, 3.1459 truthy. It turns out that all numbers are truthy except 0. So 0 is the one number that's going to be considered falsy. That means if we pass 0 into an if statement, the else, or as the condition of an if-else statement, the else bit will be triggered. So there we go. The other variables we might want to play with are undefined, which is falsy, and null, which is falsy. So of these primitive data types that we learned last night, we now know the rules for figuring out if they're going to be truthy or falsy. And as a general rule, we can think about it as if there is data, it's considered truthy. So any string is going to be considered having data, except the empty string, which is kind of missing data. Any number would be considered having this content, except 0, which is kind of nothing. And then, of course, undefined and null directly represent data being missing, so those would be falsy. So truthy and falsy, I remember when I first learned this, and I was coming from Java, in which case types are very strictly enforced in Java. So I already thought JavaScript was weird. And when I learned this, I thought it was super weird and was like, this will never be used. Why are we learning this? This is super stupid. And then I learned pretty quickly that this truthy falsy thing is actually super useful. So let me just show you a quick example of where truthiness, where I personally use truthiness all the time. So let's say that we were getting some sort of info from a user. We might be getting a name and an address. Anyways, so we're getting some info about the Steve character. So we might want to have some bit of logic that, you know, executes. And actually, let's say this is an email address. So we might have some bit of logic that's supposed to send Steve an email. So this logic might crash if his email data is missing. So we might say if email, and then we type in some logic about sending him an email here, which I won't fake out. So in this way, the logic only runs if the email exists. So if this is blank, so I'll throw a console log in here to clarify. So console log email sent. So right now when we run this, we'll send him an email. But let's say that this were missing. Maybe it's just a blank string, or maybe it's actually set to null. In that case, we wouldn't want this logic to run because we'd probably get an error because the email is missing. So it's really nice to be able to do that. On the flip side, we could also write something that said, if no email, or in other words, if email is missing, then Error, missing email. So it's a good way of error checking, whether we want to officially error check or just only run a bit of logic if something is present. It's really nice to have this tool, and in that way we can check in one fell swoop for nulls, undefines, and blank strings. So really great. And this brings me to another point, which is that this truthy falsiness thing is kind of cool when it comes to our not operator. As a reminder, not can be used with true and false to turn them into the opposite. And I think there was a question last night about, like, what's the point of that? That seems kind of weird. And sometimes that's useful, but it becomes super useful with these truthy things. So if we wanted, for example, to, if we had some mystery value, maybe it's set equal to a number, and we wanted to turn this mystery value into a Boolean, we just double not it. So double not is going to turn it, because this is truthy, it'll turn it to false and then back to true. So this double not operator will take a truthy value and turn it into the actual Boolean value of true. So this truthy value of 3 with the double not becomes the actual Boolean value of true. If we did this with 0, which is a falsy value, the double not will turn it into false. So you'll see a little bit of this on your homework tonight. And just remember, the double not is just a nice way of turning a truthy or falsy value into the actual Boolean value of true or false. All right, so there is truthiness. Let's talk about some other fun stuff that we can do with if-else statements. So we've now seen that we can put in inside of an if-else statement, we can have our condition be an actual Boolean. We could have it be a comparison, or we could have it be a truthy or falsy value. So there's another thing that we can put inside of our condition, which is a logical operator. So a logical operator is a way of combining trues and falses together to get more trues and falses. So if you've ever studied formal logic before, whether it was in a philosophy class or a math class, or you just study formal logic in your free time, some of this will look familiar. If you've never studied formal logic before, we're about to do some formal logic. So yay. And I'm a total math nerd, so I love formal logic, but you guys might not agree. But anyways, let's talk about some logical operators. So for starters, we're going to learn about and. So and is a logical operator where we want two things to be true. So let's use this example. Let's say that we have, it's raining, but I have an umbrella. Wait a minute. That's not a good example. Sorry, guys. Trying to come up with good examples on the fly here. So let's say that it is raining and I'm wearing sandals. Cool. So if it is raining and, so the and operator is the double ampersand, and I am wearing sandals, then there's no way I am going for a walk, right? Not going to go for a walk if it's raining and I'm wearing sandals. So we might say not going for a walk. No way. And this will work. So if it's true that it's raining and it's true that I'm wearing sandals, then this will resolve to true. So when we and two values together, if they are both true, it becomes true. However, if one is false, so let's say I'm not wearing sandals, then I'm maybe willing to go for a walk. So the and statement does not come together. If it happens that it's not raining, but I am wearing sandals, well, then I'm still willing to go for the walk. And if both are false, if it's not raining and I'm not wearing sandals, then I don't care. So in summary, when we're anding two logical values together, so we and Booleans together, they become a new Boolean. So we combine two Booleans to create a new Boolean. And with the and operator, both have to be true to get a true. So for and, true and true gives us true. But if we had false and true, that would give us false. If we had, I won't do true and false because it's the same thing, but if we had false and false, that gives us false. So think about and as being picky. It's only going to resolve to true if both things are true. And this turns out to be really useful for examples like this one, where we might have two conditions that we want to be met in order to run our if block. So that is our first logical operator. Our next logical operator is called or, which is at least one must be true. And we use the double pipe for or. So with ors, if we have true or true, that's going to resolve to true. If we had true or false, that would also be considered true. We just need one condition to be met for or. And then finally, if we had false or false, then that's going to become false. So let's do a little or example here. So let's say that it is, so raining is equal to true and umbrella is equal to false. So if it's raining or if I have an umbrella, then I'm willing to go for a walk. Wait a minute, that doesn't make sense. Let's, sorry. Let's set this, I need to come up with some predefined examples in advance so you guys don't have to watch me flounder. Okay, so if I have a raincoat or an umbrella, then I'm willing to walk in the rain. I don't care, I don't need to have both. I just want to have one or the other. Okay, cool. So in this example, I have a raincoat, but I don't have an umbrella, which is totally fine. I'm still down to walk in the rain. If I had both, that would also be okay. Still down to walk in the rain. However, if I didn't have either, then I probably don't want to go for a walk. So in this case, because they are both false, this resolves to false. So we can think about and as being super picky. And requires both statements to be true, or is like your casual friend who's down for whatever, or is like, hey, you know, one can be true, the other can be true, they both can be true. But if both are false, then or is going to become false. So or and are really useful ways of combining logic together to create more logic. And it turns out that these things can get pretty complicated because sometimes you might be doing, okay, if I don't have a raincoat or I have an umbrella, or maybe if I don't have a raincoat or I have an umbrella and a poncho, etc. So this starts to get crazy, right? Because we can actually combine ors and ands and nots all together for a complex statement. So I'm not going to get too much into those, but you will have a lot of fun tonight playing with this formal logic stuff on your homework. So those are ors and ands, just another way that we might set up our if-else statements to be a little more sophisticated. Okay, so there we have logical operators for you guys. The last thing I want to show you with if-else is something called an else-if. And I saw someone mention this in Slack. So this is also called elif sometimes, but I think that word is kind of stupid, so I don't use it. Sorry to be judgmental of you, elif, but yeah. So else-if statements are used when you want to have multiple options. So notice that in this case, I have option 1, and in the other case, I have my option 2. And as I mentioned last night, one of these two is going to run. Either we're going to get option 1 or option 2, never both, never neither. But sometimes we might want 3 options. So let's say that we're trying to figure out if we should, which direction we're trying to go. So if we are facing north and we're trying to figure out which way to go, we might be curious if we're supposed to turn Okay, so we're facing north and we turn. So we want to, uh-oh, my mom is texting me during the class. That's awkward. Sorry, guys. Everyone's trying to get a hold of me tonight. Okay, so we're facing north and we want to turn right. So we might say, okay, if turn is equal to right, then let's see, then I would be facing east. So we'll console.log, go east. Cool. And we might say, okay, else turn is probably equal to left. So we'll console.log, go west. But what if turn was equal to around? Then we'd get go west, but that's not quite right. So we need another option here. So we might say, else if turn is equal to, oops, left, then we want to go west, and then we could put in another option. Else if turn is equal to around, and we want to go south. So notice that now with my else if statement, I put in 3 options. So it can now check if we're going right, if we're going left, if we're turning around. And whatever this is set to, it'll work. And what's cool about else if statements is we can still have a default. We can still have a if all fails statement. So we might say console log. If we're staying straight, then we just want to go north. So if this is set equal to turn up, then we're still going north. Or turn over, still going north. So in this way, I've actually set up an else if statement that has 4 different options with 3 different conditions and then 1 default. So that is an else if statement. Those are really common, and I think someone had mentioned in Slack that they worked with these in Python. So most languages are going to have not only if else, but also else if. So if else's are really common. A lot of the times there's only 2 options, but plenty of time you also might want to be a little more sophisticated, in which case an else if statement is the way to go. All right, so let's go ahead and actually, I just saw a really good question in Slack that I'm going to address right now, which is this question of what's the difference between doing this versus just having 2 if-else statements. So let's say that we just had if turn equals right. I'm going to comment all this out real quick and show you why it's important to have 4 options. So if turn equals right, console log, actually I'm going to do some copying and pasting. Sorry, 1 second, guys. Okay, let's split this up into 2 different if statements. Okay, so now instead of using an else if statement, I've done 2 different statements. So the problem here is that we get 2 different contradictory messages. Let's explore why. So the first if statement ran, and we said, if turn equals right, do this thing, and turn does equal right, so we ran this code, and then we skipped the else. Now we went over here and checked this condition, and that wasn't met, so we defaulted to else. So the problem is that in each of these, something's going to run, one or the other. And that's not right. We don't want 2 things to run, we want just 1. So what happens in our else if statement, which is why it is better in this example, is only one of these 4 options is going to ever run. We'll check the first condition. If it's met, we don't even bother with the rest of the conditions. If not, we move on and check the second condition. If this one's met, then we execute the code and we're done. But if not, we move on. So we keep going down the line and checking conditions until we find one that works. And then at the end, we default. So in that way, often it is useful to actually do else ifs instead of trying to break things up into multiple statements. Because with multiple if statements, we don't really have 4 options. We just have 2 different sets of 2 options. So hopefully that answered that question. Okay, let's do the very last thing I want to show you tonight with control flow, which is kind of a totally new topic, but really useful. And that is looping. So let's say I wanted a bit of code which counts to 5. So I might say, and I'm going to start at 0 because as programmers, we start at 0. And you will see more examples of why that is as we go along. So I might say, okay, console.log 0, console log 1. This is getting tedious. I don't want to write this a million more times. Why am I doing this? La la la. Okay, here's one more. And there we go. So I've written out 5 or 6 lines of code to count up to 5 from 0. And it does work, but it is not dry. So dry is a concept I will be hounding you with for the rest of this course. Don't repeat yourself. Sometimes you do, there's no way around it, but most of the time, if you're writing code where you're writing the same thing over and over and over again and just changing one little piece, that is bad code. There is a better way to do it. And in this case, the better way to do it is with a loop. So let's do this a better way. So now in really just 2 lines of code, since that line is only a curly bracket, I have written the same logic and it is now way dry. So now I haven't had to repeat out this console log a million times. So this is a loop. What I have just done in these couple of lines of code is say, hey, start a loop at 0, end a loop at 5, and then every single time we loop through, go ahead and console log whatever our counter is on. So for loops are basically what we do is we create a counter variable and then we change it until our quit condition. So we need a starting place. We need a rule about incrementing or decrementing or changing, and then we need a rule about when to stop. And that's everything that's going on here. So let's break down the syntax here. So the for loop starts with the keyword for, and then it's followed by parentheses. And as you might guess, just like with the if statement, there are conditions inside of these parentheses, though the for loop conditions are a little more advanced. I'll break those down in just a second. So we have our keyword, and then we have a set of conditions inside of our parentheses. Following that, we start our for scope. So just like the if and the else statements had a little bit of scope, we also have something similar happening in here. So we have a little block scope going on inside of our for statement. And everything inside of the scope will run every time we loop through. So as long as our conditions are still looping, this line of code will repeat. So this line of code, even though I've only written it once, actually ran 6 different times, and with I set equal to a different value every time. So let's look at these conditions. The first thing we write is our starting condition. And we always want to declare our counter, which by default, we always use I as our counter, with the let variable, because our counter is going to be changing throughout this loop. So we would have a problem if we tried to instantiate our counter using const. So we always want to use let for our counter. And by default, we're going to start it at 0. There are many cases where we might not, but by default, we would start our counter at 0. And then we put in a semicolon to indicate next condition. So our next condition tells us how long the loop should continue. And this will be a Boolean statement involving I. So in this comparison statement, I've said I is less than or equal to 5. So I is going to start at 0, and as long as I is less than or equal to 5, we want to continue. Once it becomes greater than 5, then we're done. And then finally, we want to be able to change I in some way. So this is our start. This tells us when we want to continue. And then the last one tells us how to change our counter. So I'm using the plus plus operator, which we learned last night, which will increment I every single time. So let's actually just change this to 3 really quick. Run it. And let's break down in excruciating detail what happens. So we start out with I set equal to 0. So I starts out at 0. We're going to then run our loop. Well, first of all, then we check, is our condition still met? And it is. 0 is less than or equal to 3. So we do condition is true. So we continue. Then we're going to run our loop. So we run all the code in here, which is just this one line. So we're going to log 0. And then we check, and then we actually increment it. So then we do I++. So now I is equal to 1. We check our condition. Of course, I is still less than 3, so that's true. And then we're going to actually run what's in the loop scope. So we will log out 1. And I'm not going to continue this indefinitely, but let's do one more. I increments. We check our condition, et cetera, et cetera. We log 2, we log 3, and then at some point, we increment up to 4. And in that case, our condition is false, so we quit. So I is going to become 4, but this will fail and jump us out of our loop. So this line of code will never run. And that is how we loop. So we could do a lot of different cool things with looping. By default, we might want to start at 0, but we could also go backwards. So let's say we wanted to start at 5 and loop as long as I was greater than 0. In that case, we want to make sure that we're actually minusing. So now notice that I starts at 5. We continue as long as it's greater than 0, and we decrease it every time. We could also say, instead of decreasing, in that way, we might say decrease I by 2. Remember the plus equals minus equals says let I be redefined to 2 less than what it is. Now we're jumping down by increments. A bit of clarification though. If we just did I plus 2 over here, we haven't actually changed the value of I. We talked about this last night. Just doing I plus 2 doesn't change the value of I. So if we did that, we would have an infinite loop because we're stuck forever at 5 because we've kind of dropped the ball on our change step. So you want to make sure that I is actually being redefined in the change, or else you'll end up with an infinite loop. Luckily, Replit will catch an infinite loop, so you won't have horrible things happen or have your browser crash. Another way we might end up with an infinite loop is, notice that I've started I at 5 and I'm increasing it, which means that I will always be greater than 0. So it's going to just keep incrementing up until almost 10,000 until Replit says, hey, stop it. Another common pitfall with loops is we might, for example, say, all right, start I at 0 as long as I is less than 0, I++. Notice that the loop never ran. That's because we started I at 0, but our condition failed from the get-go. I is already less than 0, or already not less than 0. So we really have to be mindful about what we put in here and make sure that it's sound, because we might get an infinite loop, we might get a loop that never even runs, or we might just get a loop that doesn't behave the way we expect. So this is a skill that, will come. You'll be able to write loops in your sleep soon here, but it does take a little bit of practice. So there's a lot of the homework assignments focus on really getting down what we're doing. As well, just a little note, I've just been console logging I down here, but we could do anything we wanted with I. We could console log negative I. Well, let me set this up so it actually runs. 1 second. We could do negative I, we could do I times 10. We don't even have to console log. We might do something else in here. So I will be available to us within our loop scope. And we can do available. We can do whatever we want with I in here. But if we tried to console log I outside of our loop scope, it doesn't exist. So another little example of how scope works. This I that we've created only exists within here. And that's really good because we want to be able to use, we might want to be able to write 10 loops or use I somewhere else. And it's nice that it really only exists as long as we're looping, but after we're done, it is gone. So I is not available in the global scope. So kind of bringing everything full circle. The last thing I want to show you with loops is, and this is another bit of scope, is that there are two keywords that are available within our loop that aren't really available publicly. So out here, if we tried to do continue, it would error out. It says unsyntactic continue. That's because continues are not meant to be used globally. These two keywords are only meant to be used within a loop. So let me talk about continue and break. I've always thought these were kind of confusingly named, so especially continue. So continue says stop the current iteration, continue the loop. When I say iteration, I mean each time that we loop through and this logic runs, that's an iteration. So every single time that line 8 runs is considered a single iteration. So let's say that we just hate the number 3. So we might say, okay, if I equals 3, continue. So what I'm saying here is if I is equal to 3, I don't want to log it because I hate this number 3. Otherwise, we'll console log I. So now we run our loop and everything is logged except 3. So in this case, when it hit the keyword continue, it didn't read the rest of the code inside of the loop, inside of the for. It just jumped out and started the next iteration. Break stops the loop altogether. So maybe we hate 3 so much that we don't even want to keep looping afterwards. We're just so disgusted by this letter, by this number 3 that we're like, we don't even want to keep looping. So now we get up to 2, but because we use the keyword break, it just quit the loop altogether. So continue quits the iteration, but continues the loop. Break just quits the loop altogether. So those are 2 nice little keywords that allow you to do some cool, sophisticated stuff with loops. And you'll have some opportunity to practice those as well in the homework tonight. So on that note, let me go over the homework tonight briefly, and then I will open the floor to questions. So you have 2 different exercises tonight in Replit. The first one is oriented towards reading code. So, and this will help you practice with conditionals. So for example, on question 1, you would see that this result is equal to true and false. And so if you're like, okay, I think that true and false is equal to true, you could assign that as your result answer. If you're like, no, I'm pretty sure true and false is actually false, and so forth. So you can go in and play with it that way. So that's all this question 1 is increasingly more complex and or not statements. There's some opportunity to play with truthiness, to play with falsiness. So there you have it. That is that is exercise 1. Exercise 2 is all about writing loops. So what you'll do is, you might have a loop where the conditions are already set and you have to write what goes inside of it. You might have to write some loops from scratch. I think there's a couple examples where you actually have to write the condition yourself. So that's pretty fun. And then there's one little else if example here to practice that as well. So this one's going to be, I think, take most of your time, but exercise 1 can be a little tricky too if you're not used to logic. So have fun with those. And then before you go and tackle those, I will open up the floor to questions. So let's go ahead and I'll scroll up and see what's been asked so far, and then we'll address some other questions as well as they come in. All right, I saw that, just want to make a note about this because I think it's kind of interesting. We had a loop posted in Slack where the user went up to, I don't know, 1 million or something. and they noticed that they got a potential infinite loop error. So this is not an infinite loop. This will stop eventually. But because Replit has this built-in catch, because this loop is so big, it went ahead and said, hey, stop it. We're worried about you. So you can disable, as it says, you can disable this infinite loop catch, but you might not want to just yet because we're still learning. Okay, here's a good question about scope. So let's say that we have let I equal 5, and then we have an if statement. And then we let I equal 2. And then we console log I. And then let's console log I below. So just to clarify, I've actually declared this variable twice. And we're allowed to do that because the first time I declared it in the global scope, and then down here, I declared it in the if block. So what happens when we do this is within the if block, we're going to use whatever this value of I will overwrite whatever exists globally. Just temporarily though. So that's another really nifty thing about let, is that we can temporarily overwrite this global variable within here, and then we can console log it, and it is equal to 2. But once we get out of our if statement, this global variable hasn't been negated. It still exists. So our second console log, just to clarify, down here, I is still equal to 5. But in here, we've overwritten it, and I is now equal to 2. So that's kind of a cool thing that we can do with scope. Great question. Okay, so we had another question about different types of loops in JavaScript. So there are a couple different loops in JavaScript. There's the for loop that you've seen. There's something called a for in loop, which you will see next week. There's something called a while loop, which we don't cover in this course because honestly, you almost never use the while loop, but I'll just show it to you super quick. So it's basically like while I is less than 10, so I'm going to say let I equal 0 while I is less than 10, and then I plus plus. So here's our while loop. We've done something similar to what we've been doing, but notice that my condition or my change condition and my start condition have to exist outside of the loop. So the while loop is kind of just like a weak for loop. So honestly, it's not used very often. It does exist. And then the last loop, my personal favorite loop, is called the for each loop. And we will learn this 1 week from today. So you have 2 more loops in store for you next week to get excited about, as well as this other loop that we don't cover. So there you go. There are and this is at least kind of this while and for loop are pretty standard in computer programming. So there are some other loops in JavaScript for you, some that we will see later and one that we will not. Okay, so we have a question about getting a delayed count. So I'm assuming what you mean is that if we actually wanted 0 to appear over here and then a pause, and then 1 to appear and then a pause, and then 2 to appear and a pause, etc. And there's something called a timeout that we could use to do that. So I'll do set timeout JavaScript to show you guys. So there's something called the set timeout method, and we can use that to delay things. However, I don't want to get too crazy with the set timeout method because it is something called a higher order function, which we will be learning on our very last night of this course. So I don't want to bog you guys down with the higher order function. If you guys are still curious about set timeout on Thursday, next Thursday, ask me about it then and we can talk about it. So yes, there is a way to do it, but I don't want to show it to you guys just yet. Okay, we have a little question about commenting up there, just a useful thing to know. So when I write code, If I want to comment out a bunch of lines of code, what I'm doing here is I'm just highlighting it and doing Command/. And it's probably Control/ on Windows. I don't know offhand. So that's really nice for easily commenting this out. There's another type of comment, though, that, oops, looks like, I can get it. Sorry, the autocomplete is destroying me right now. Okay, there's another type of code comment that we can do like this. And a lot of the times you'll see big formal comments at the top of code that look like this. So documentation, this code is great. Use it for things. You might see some, a comment at the top of your code that looks like this. So this is another way of doing multi-line commenting, just to be aware of. But most of the time, honestly, unless I'm trying to look formal, I just use the // or use the command/. And a lot of text editors have that exact same command in them. So there's a little note on commenting. All right. Well, everything seems quiet in Slack. Hopefully, oh, I see that someone is saying that the video has stopped. That's not good. Hopefully it's working for most of you guys, but we are pretty much done for tonight anyways, so. All right, so that is control flow for you guys. Last night we laid down the basics of JavaScript types and declaring variables. And tonight I've given you a few more tools in your toolbox for actually making interesting dynamic code that responds to conditions and changing variables. So you'll have some fun opportunity to practice that in the homework tonight, lots of logic, lots of looping, and then that is it for this week. So we will resume on Monday of next week, another 4 nights of JavaScript, and then we are done. So I hope you guys have a great weekend. Feel free to go over and try to catch up on some stuff. But honestly, I mostly encourage you to just take a few days off. You'll find that your brain is nicely rested and ready to learn cool stuff next week. So don't work too hard on this weekend, and I will see you on Monday. Have a great night, you guys, and enjoy the homework.